Hello there, I'm Saem. We will dive into Igcse Computer Science 0478 and we'll look at one of the recent past paper. The most important thing about these tutorials will be that I'll be giving you one very important point, how to get distinction or at least an A star while we discuss these papers. With 23 years of experience with 7 distinctions, I'm going to make you ready for another distinction, and inshallah we'll be working hard for that. At least let's go for an A star. It's so easy, believe me, it's nothing. You just have to make your notes. Remember to note down the key points that I mention in every video. They will always help you out. They will be anywhere between the video.
Saem and Tariq. We'll be solving paper 1 Computer Science 0478 May June 2024. Okay, so stick along with me. I'll be trying to explain you each and every part. For more detailed lectures, you probably have to go to my YouTube video links, which will be in the description. Data can be measured in bits. Give the name of the data storage measured that is equal to 8 bits. So obviously 1 byte, as probably all of you do know, is equal to 8 bits, right? State how many bits there are in kilobyte. So obviously 1 kilobyte is 1024, as 1 kilobyte is 1000, and if you multiply this by 8, you will come up with the following value. So being a computer science student, there are some of the multiplications and divisions that with practice you would obviously learn them by heart. This is the reason why I did so fast, because obviously been teaching it long. Give the name of the data storage measurement that is equal to 1024 gigabytes. Obviously that is actually 1 TB byte. Okay, it's also known as TIB with ice ball. A 16 color image has a resolution of 512, okay, pixels width, and 512 is also the height. Calculate the file size of the image in kilobytes showing your working. So first of all, what we need to do is we need to calculate the total number of pixels. So if we want to calculate is the total number of pixels, we will be doing so by multiplying 512 into 512, which comes out to be 262,144 pixels. Then obviously we do know that how many bits per pixel. We do know 16 bits color. We know that. So in order to calculate the total number of bits, we will be doing what? We will be doing is the value that we just got, 144, it has to be multiplied by 16. So once you multiply it by 16, we will be getting over here is, let me just do my rough working. So we'll be getting is 4194,304, and these are the bits that we have. If now we want to convert bits into bytes, so obviously all we have to do is we have to divide this by 8, and we get is and further, if we want to convert bytes into kilobytes, we will divide this by 1024, and if we do so, what we get is 512 KB, okay, which is also equivalent to 0.5 MB. So we have over here is 512, the answer. Data can be transmitted from one device to other device. Take one box to show which of the term is not a method of transmitting data. So out of this, parity is not. The rest of them are. Data is broken down into smaller units to be transmitted from one device to another. Give the name of the unit that data is broken down into. So it's known as a data packet. So I have a very elaborated lecture of mine where I've discussed your protocols. Data is often encrypted when it is transmitted from one device to another. Explain how data is encrypted using symmetric encryption.
Explaining the difference between symmetric and asymmetric encryption. As far as your symmetric encryption is concerned, there is just one key which is shared between the both ends. So this was not a very good way, because obviously if someone gets hold of that particular key, although it was kept secure, you would obviously be able to decrypt the message. There had to be a better way. This is where the difference between HTTP and HTTPS came in. HTTP 5 years back, 10 years back, now it's not being used anymore. Okay, so if you have a website which is based on the domain of HTTP, Google is going to rate it at the very end. So HTTPS, it's secure. How is secure? Because it uses asymmetric encryption. What's asymmetric encryption? Okay, let me explain you. So it's a very different way. So think of a box, and that box actually has two keys. One is a private key, one is a public key. You have the keys of the box. What you do is you open the box, okay, and you keep the key. And what you do is you send the box to the server. Anyone in between, obviously there's no data, so why would someone intercept? The box reaches the server keeps your requests, whatever that request is. It could be a message, it could be an attachment, it could be a request of a web page, and it will close the box. The box is locked. Now the box will be sent back to you. Now once the box comes back to you, in between, if someone tries to intercept, gets hold of it, he or she will not be able to open it. Why? Because I only have the private key. No one else has the private key. Yes, they might have the public key, but I am the only one who has the private key. So I can now use my both keys to open the box and I get the message. This is how, when we use HTTPS to browse different websites, you actually have a private key generated every time. So you can have a lot of, gazillion sorts of keys generated. You can also go to the properties and you can see the public key over there. It's an hexadecimal. So this is the basic difference of it. You can go through my lecture to have more detail about this if you want to understand it. Thank you.
So we have over here two kinds of encryption, symmetric encryption and asymmetric encryption. Again, I will share a link of the video where I've elaborated this to a lot more extent. Remember that whenever we talk about symmetric encryption, we are talking about same key which is used for encryption and decryption. So first of all, same key will be used for encryption and decryption. Okay, so first of all, the key will be generated. Okay, now obviously the will generated and the original data, which is also known as the plain text. Plain text will be converted into ciphertext, okay, using the secret key and the encryption algorithm. Then the data, I'm not writing it, just have write it down yourself. Then we have is the transmission. Obviously, this ciphertext is sent over the network, and then we have the decryption that will take place. And this decryption that takes place will have what? It will use the same secret key to convert the ciphertext back into original plain text. Okay. Why do we use? Next part. Give the purpose of our encryption. Obviously, encryption is there to make the data more secure and to make data not to be read by someone else. It cannot be intercepted. So now what we have is binary is base 2 number system. Give the name of the number system with a base of 16. We have over here is hexadecimal system. So hexadecimal system is base 16, just like base 10 is decimal system. 3 binary numbers are entered into computer. The computer converts the numbers and stores them as binary. Give the binary number that would be stored for each of the denary numbers. So there is this conversion grid that I always use to teach my students. By conversion grid, what I mean to say is I write over here is 1, 2, 4, 8, 16, 32, 64 and 128. There is another method by division, but this is also fine. You can use either of them. So if I want 10, I would do is I write 0, 1, 0, 1. So because if you add 8 with 2, you get is 10. In the same way, if you want to write 50, what I would do is I write is 1, 1, 0, 0, 1, 0. Because in that case, what I'll do is I'll be adding 32, 16 and 2, which will be equal to 50. And if I want is 201, very interesting, I would be writing over here is 1, 1, which is 128 plus 64 plus 16 and plus 1. Okay, so what I need to say is if we add this 128, if we add 64, if we add 8, and if we add 1, this will be equal to 201. I hope you got my point. Okay, you can do the working over here. Explain why data is converted to binary by computer. Well, obviously, in order for a computer to understand, it has to understand in zeros and ones. Digital electronic devices use electrical signals that use two states, which is 0 and 1. Computers are built using transistors. So transistors are tiny switches. Okay, remember that they're tiny switches. So these switches can either be on and off. So we have logic gates. If you have straight logic gates, we have the AND, NOR, NAND, XOR gates, and all of these gates will always use zeros and ones. Okay, that's the reason why we use it. The two binary integers over here, which is this and this, are added together. Add the binary integers using, so we have to add both of them. So let me just write them down 1 second. 0, 1, 1, 0, 0, 0, 0. Then I have 0, 1, 1, 0, 0, 1, 1, 0. So remember one thing, let me first of all help you with writing the rules. So remember one thing, that if I have over here is 0, 0, that will be 0. If I have 0, 1, that will be 1. If I have 1, 1, in that case it will mean is 0, and we will be carrying 1. And if I have 1, 1, I will have 1, and I will be carrying 1. So that's the rule. Let's use the same rule over here. So if I have over here 0, 0, I'll have 0, 1, 1, 0, this would be 1, 1, 1, 0, 1 comes here, 1, 1, 0, and then we get 1. So that's the answer. The denary integer minus 32 is stored as 2's complement. Remember that? Calculate the 2's complement integer that would be stored. I'm using red, let me keep on using red. Now 2's complement, there's a rule for that, you need to remember that. What is that? Well, if in 2's complement, if I write over here is 1, 0, 1, 0, 0, 0, 1, just give an example. The very first one, if this is 1 in 2's complement, it means it's a negative value. If this is 0, it means it's a positive value. So if this is 1, it's a negative value. If this is 0, if it is positive value, just have to remember this very important rule about writing it all in a 2's complement. So in this particular case, if I want minus 32, okay, how would I do that? Well, in that particular case, I would be doing is, I would be writing over here, let's say, let me put this into a conversion grid first. So I have over here is 1, 2, 4, 8, 16, 32, 64, 128. Now if I want minus 32, what I'll do is I'll convert this into minus. So what I'll do is I'll write over here 1, which is negative. Minus 128 plus 64 is minus 64. Minus 64 plus 32 is minus 32. Okay, so the rest of them can be converted into 0. So this is what we get as the answer.
Our key point for this video is that whenever you're attempting the paper, just scan through the paper in the next 2-3 minutes. It won't take much time. 5 minutes, let's say it. You're not wasting your 5 minutes, you're actually saving your 5 minutes. You know how? Because you will have an idea, okay, you know what? I have some doubt about this question. Leave it till the end. Complete those questions which you're 100% sure of. Come back and you give more time to these questions. This way, you will actually save time as well, and you will have more time to spend on these questions which you had left. Otherwise, you'll just scramble through, you will omit, write again. That's not a decent way of attempting a paper.
A student uses both system software and application software on the computer. Give one example of system software. System softwares include your operating system and also your utility programs. Now remember something, operating systems and utility programs help the system, the computer system, to work more efficiently. Okay? Application softwares are those softwares that help the user directly to perform some sort of application, such as using the spreadsheet program. Spreadsheet program you can use for mathematical modeling, okay, for accounting. You can use databases to store data. You can use presentation authoring. You can use word processing. So these are applications, graphic softwares. Okay, what is the difference between system software and application software? System softwares basically are used. Why? System software, they are used to make the computer functional. So the way we always explain an operating system is, an operating system is an interface between the user and the hardware. If the user wants to interact with the hardware and the software, there has to be an operating system. So it helps to manage the hardware and the software, and in order to help the user to interact with the hardware and the software. As far as the application software are concerned, they are used to perform some specific tasks. Instructions are processed by central processing unit on your computer. Complete the paragraph about fetching an instruction into the CPU to be processed. Use the terms from the list. Some of the terms in the list will not be used. You should only use them once. Okay, let me just go through this once. Okay, so yeah, actually I had to sip my cup of tea as well. Okay, the program counter contains the address of the next instruction to be processed. This is then sent to the dash using the address bus. This is sent to the memory address register. Okay, the MAR. Again, I'll share a lecture with you of this entire topic. If you don't have an idea about it, you have to go through the lecture thoroughly in order to have a full understanding of the von Neumann architecture. Only then you will have a full understanding of all these registers and what role do they play in the fetch, decode, execute cycle. The address is then sent to the RAM, obviously. This is how it happens. Once the address is received, the instruction stored at the location is sent to the MDR, the memory data register, using the data bus, obviously. The instruction is then sent to the current instruction register that is built into the CU, control unit. CPU uses an instruction set to decode the instruction. What is meant by instruction set? Obviously, instruction set means all those list of commands that you have to be processed by CPU. Okay. The table contains statements about error detection. Complete the table by giving the correct error detection method for each statement. So here we have this add. So or processing, this is over your parity check, which is known as even or odd parity. Values calculated from the data using an algorithm, which is checksum. The copy of the data is sent back. Remember, when this copy is sent back, we call it an echo check. It goes, let's just like the echo test. It reflects and comes back. It's an echo. Acknowledgement and timeout are used. It's ARQ actually, which is actually stands for automatic repeat query. Values is appended to data that can be calculated using the data. We check digit for that. Okay, check digit is a way which is also used in your barcodes as well. A computer has both media control access and IP address. Take one box to, so a MAC address is a physical address which is embedded onto the device. So it is obviously the first one which is assigned by the manufacturer. So MAC address, it's embedded on every device physically. An IP address can have an IPv4 or IPv6 format. Give an example of IP address that has an IPv4 format. So example could be 106.210.10.0. So that's the example. Okay, that's the example of your this. So you have to remember one thing. But you should know a lot about IPv6 and IPv4. You can get a lengthy question about it. Two features of an IPv6. IPv6 is basically your 128-bit long unique IP address. It basically allows 340 undecillion possible addresses. It is separated through colons. For example, we can have over here is 21AC colon 0380 colon 7334. So it can have hexadecimal. So you have over here is four groups in total of 8. So 1, 2, 3, you'll have 8 of these separate through a colon. So you can also mention that we have this, and we can also mention we have colons. So that's the way you can explain this. A company has a website that is suffering distributed denial of service DOS-stack. Draw an annotated diagram to show. So if we have over here is a client, and if we have over here is a server. So basically, what's a DOS-stack? DOS-stack is that whenever there is some sort of worm or virus that keeps on sending requests to the server again and again so many times. So for example, you have over here these are what we are referring to these as bots, and these bots will be doing what? These bots that I have, okay, please draw a better diagram. So these bots will be requesting to the server again and again, okay, for certain requests. So if your server can cater for 1000 requests per second, and if your bots are sending 1001 requests, obviously if a legitimate client comes in, which is 1002nd client, it will not be catered for because the server will be too busy with those bots which are actually putting the server to its extreme, and it cannot actually, so it denies its service. This is what denial of service attack means, that I cannot cater for your requests, so sorry, I'm down right now. Okay, identify a solution that can be used to help. Yeah, we can use a proxy server, or we can use a firewall. Okay, a company uses both solid state and optical storage device. Explain why computer needs second storage: to store the data permanently, to be reused again and again. Okay, Describe three, and it has a lot more data. Describe three differences between solid state optical. Yeah, verbally I can discuss. Solid state consumes less electric current. 1. Second, solid state takes less space. 2. Third, solid state works really fast. 3. Solid state can store more data, and vice versa optical storage cannot. Okay, solid state does not have moving part. Optical storage has more moving parts. Okay, so there are numerous differences between both of these. Frankly speaking, you should have a chart which explains all of these more thoroughly. Okay, a guide using Igcse system to help diagnose any problems with cars that we repaired. The Igcse system is an example of AI. What is meant by AI? So AI mimics humans, okay, and creating like a real life like situation. Okay, a car has
Igcse system has a lot of detail. You have to make sure that you make your notes relate to this. Igcse systems can go beyond the scope of the book, the syllabus. So make sure you know how to implement an Igcse system in any particular field. So go through the lecture below. I've given a description of
the problem with its braking system. It is brought into garage. Explain how an Igcse system operates and how it can be used to help diagnose the problem. So first of all, you will have over here is okay, so you have to talk about is the GUI, the graphical user interface, or the interface. Okay, the question will be given in GUI. Then your inference engine comes in. Now, what's an inference engine? An inference engine helps you to get the data from the knowledge base. What's a knowledge base? That includes all the details about one particular field, area. Experts' knowledge are in the knowledge base. So knowledge base data goes to the inference engine that retrieves the information, which is then elaborated, explained in your explanation system before it is given to the user to make it more meaningful. And what we have then is the output. So if I want to elaborate this more, I would explain that inference engine uses rule base. What's rule base? Rule base consists of if then else statements. So if you find this, you will do this. Okay, so that's how it all works. You are going to explain this in your own words. Hope you get my point. Any confusion, please write it in the comment box. A company has a website. Users use internet and World Wide Web, okay, to access the website. Okay, so describe the difference between internet and World Wide Web. Internet is an infrastructure, remember that, and the World Wide Web is a collection of web pages. The website has URL. The URL has three different parts. Identify three different parts that are used in a URL. So we have over here is a protocol. We always have that. We have is the web page name, and we'll have is a domain name. Okay. So for example, you have is let me write it fully like https dot saem.com. That's your protocol. That's your web page name. That's your domain name. .com, .net, whatever. One function of web browser is to provide an address bar for the user to enter a URL. Give other three functions web browser. Okay, to store the history, to have a bookmark, to store cookies, to go back and forth. Okay, onto the home page. Okay, so all of these things you have, favorites and all that. This is what you have. Okay, so this was the paper. We will be discussing another paper next time. So till then, see you all.
I hope you got all the points that I explained in this paper. If there still are any issues, do write down in the comments and let me know. I will try to elaborate them more. See you till the next lecture, where we will discuss another paper, probably paper 2 of the same year, so that your doubts are clear and you're ready for a distinction with Mr. Saem. Thank you.